Today we're going to be learning about input and output machines which have more than one pattern rule. So below is a picture of the input and output machine that you learned how to use last year, and it only has one pattern rule. You can see that the pattern rule for this particular input and output chart is -7. So if you remember how to complete input and output charts, we have a column on the left here which is your input, then we have a column on the right which is your output. And so from going from the input to the output, you need to apply your rule, which in this case is -7. So if I start with an input of 20 and I take 7 away, then my output is going to be 13. If I have 19 and I take away 7, my output is going to be 12. If I have 18 and I take away 7, my output's going to be 11. If I have 17 and take away 7, my output's going to be 10. And if I have 16 and take away 7, then my output is going to be 9. It's pretty simple. You start with your input number, apply your output rule. You start with your input number, apply your pattern rule, and get your output number. So that's how we make this work if we have a single pattern rule, like -7. This year, you're going to be learning how to calculate patterns when you have two pattern rules, as in the case that's on the screen right now. If you have a pattern rule that has 2 or even 3 functions in your input and output machine, it works the same way as it does with one. You start with your input number, you apply your pattern rule, but this time you have 2 to apply instead of 1, and that brings you to your output number. So if we look at this specific example, our first input number is 1. The first thing we have to do to it is multiply it by 2. So 1 times 2 is going to leave us with an answer of 2. Then we have to add 6 to it. So 2 plus 6 is 8, which means that our output number is going to be 8. Now our next input number is 2. We follow the same path. We apply the first rule, so 2 times 2 is 4, and then we add 6 to it. So 4 plus 6 is 10, which means that our second input number is going to be 10. And finally, we go with the last or the third input number, which is 3. We apply the first rule to it. 3 times 2 is 6. And then we apply the second rule to it. 6 plus 6 is 12. Now, it's really important when we're looking at input and output tables that we understand that there's more than one relationship happening here. So really our rule is start at 1, multiply it by 2 and add 6, and then increase by 1, multiply it by 2, add 6. Increase by 1, multiply it by 2, add 6. But if we were to just look at this column, we would think our rule was something like add 2 each time, because the difference between 8 and 10 is 2, and 10 and 12 is 2. So we could look at this chart and predict that our output, if our input was 4, we could predict that our output would probably be 14. And then we can test our theory by applying the rule. If we take 4 and we multiply it by 2, 4 times 2 is 8. If we add 6 to 8, we get 14. So our rule holds up. So working with an input-output chart like this seems pretty simple. You start with your input number, you apply the first rule, then the second rule, and that gives you your output number. Pretty straightforward. Sometimes, though, you're going to be given an input-output chart and asked to find the rules. So there's a couple different strategies you can use, one of which is guess and check. But the problem with guess and check is that it can take you a really long time to solve the problem if you're not guessing correctly. So a second strategy you can use is to try to look for multiplication patterns, or to look for multiples. If you remember, multiples are basically skip counting by the same number. So 3, 6, 9, 12, 15, 18 are all multiples of 3. 5, 10, 15, 20, 25, 30 are all multiples of 5. So in order to kind of assess whether or not there's any multiplication or multiple relationships, we need to look at the output side of our chart. And the first thing we should do is look at whether or not there's any obvious relationship between our output numbers. Now if you look at these, we go from 1 to 4, then 4 to 7, then 7 to 10, and 10 to 13. Right away we can tell this is an increasing pattern. So we know that our pattern rule is probably going to be multiplication or addition because our numbers are getting bigger. So we're probably working with a multiplication or addition rule. Now, when I look at the difference between 1 and 4, I see that that goes up by positive 3. When I look at 4 and 7, that goes up by 3. I look at 7 and 10, that goes up at 3. And I look at 10 and 13, that goes up at 3. So the temptation is going to be to say that your input rule is plus 3. Well, it doesn't quite work because we still have an empty output rule to fill in. However, knowing that our numbers are all going up by 3 suggests that it's going to be some kind of relationship with the number 3 or some kind of multiple of 3. So if we're working with the idea that we have a multiple of 3 here, then our first input rule might be multiply by 3. So let's see what happens. If I multiply 1 by 3, that should give me 3. I'm only getting to 1. If I multiply 2 by 3, that gets me to 6, but I have an answer of 4. If I multiply 3 by 3, that gives me an answer of 9, but I'm at 7. If I multiply 4 by 3, then that gives me an answer of 12, but I'm at 10. And if I multiply 5 by 3, that gives me an answer of 15, but I'm at 13. But that's okay, because we still have a second output rule, to apply. So if the first part of our rule is multiply by 3, and that takes us to 3, 6, 9, 12, and 15, how do we get from these numbers to our output? Is there a relationship? Is there a common operation that we can do to get us there? Let's look. The first thing I notice when I look at the numbers here is that, whoops, I'm on erase. The first thing I notice when I look at the numbers here is that we have 3 and 1. Well, what's the difference between 3 and 1? Well, it's 2. If I start with 3 and I go to 1, I have to take away 2. If I look at my relationship between 6 and 4, I started at 6, I went to 4. Well, the difference between 6 and 4 is 2, and I'm making the number smaller, so I'm going to subtract, or take away. If I look at my relationship between 9 and 7, the difference between 9 and 7 is 2, and I'm going from a 9 to a 7, which means my number is getting smaller, so it's minus 2. If I look at 12 and 10, the difference between 12 and 10 is 2. I started at 12, I went to 10, so my number got smaller, so it's minus 2. And I had 15 and I went to 13. That's a difference of 2, and the number's getting smaller, so I'm subtracting. So it seems like in each case, I might be able to multiply my input by 3 and then subtract 2. Let's see if that rule works. 1 times 3 is 3, minus 2 is 1. 2 times 3 is 6. 6 minus 2 is 4. 3 times 3 is 9. Minus 2 is 7. 4 times 3 is 12. Minus 2 is 10. And 5 times 3 is 15. Minus 2 is 13. So our rule works. Our original input rule is multiply by 3 and then subtract 2. So hopefully after watching this video you have a little bit of an understanding of how to use two different types of input-output charts. One where you're given the input-output and one where you have to find it. It's time for you to do some practice.